Thank you for the wonderful introduction, and happy to be here. It's a pleasure. First time in Poland. So far, I like it. Cześć. So yeah, today we're going to talk about scalability and Ethereum. And just to get everyone on the same page, I'm going to try to accommodate the talk both for people that don't have that much experience with the topic and experience. So when we talk about scaling, we talk about the capacity of the chain to have as much transactions as possible at a price that we deem reasonable. So say if Ethereum today has 10 transactions per second, we want to scale, we want to elevate that to 100 to 1,000. More capacity means cheaper fees. And at the end, that means that we make the chain more democratic, more people can access it. Now, Ethereum is hyper-financialized, DeFi-only type of usage. If we can scale Ethereum by now, 10,000, we could have much more diverse type of activity, more things like social, gaming, etc., and accommodate other types of communities that maybe don't have the resources to pay the transaction fees that we have today. So, as you were hinting, the whole thing is this scalability trilemma. So, we could scale blockchains, and some blockchains have chosen to do that today, but they usually sacrifice something. The easiest one is decentralization. You just have chains with very few nodes that are very expensive to run, and they are run by a few cartel of people, and you sacrifice on decentralization. But in Ethereum, since Genesis, the key has been to preserve decentralization. That's what I think would make Ethereum thrive in the long term. So to motivate what I'm talking about and give you a precise example, let's understand why we are going with the rollup-centric roadmap. So consider our two beloved chains, Bitcoin and Ethereum, where, again, for decentralization, we want for everyone to be able to run a node. So we have this red line. We want to make running nodes cheap and affordable, so you can have them at your house with modest hardware and a reasonable internet connection. What that means is that we limit the throughput to the chain to the lowest spec participant. Now, if we want to scale, we can do some example of a chain I'm not going to mention, where we just make the cost of running the node more expensive, more throughput, but we lose this capacity of everyone to run nodes. Then the chain may cartelize. We have maybe, 10 BC farms running the nodes. They can start to do things. They can start to censor people. They can do irregular state transition. They can do things that are damaging and potentially destructive to the chain. And the large base of users don't have any recourse because they don't run nodes. What they have to do is they have to go to Twitter and be like, you have done something bad. No, then recover, which has happened in the past. We did it in Ethereum. It was the DAO hard fork, but it's very costly. It's not optimal. It takes a lot of social capital, reputation. It's not something we want to build Ethereum on. So what if we could automate, have this very expensive social recovery step done automatically with math? And that's exactly what rollups do. We offload execution onto these layer 2s, and then they, with these clever tricks, can prove to L1 that they have followed all the rules automatically. And if they don't do, we have this recovery done automatically. So optimistic rollups, they do it with economic games and these bisection games, and validity rollups with crazy cryptography, but the end is the same. Execution happens there. We prove to L1 that's correct. Done. Now that we have addressed execution, the next point is data. So what happens if data becomes unavailable? And with data, I mean the transactions that go into the rollup or the state diffs that go into the validity rollup. If data is not available, we are screwed. So for optimistic rollups, we have to do this bisection game. And if you don't know what's the input state to the optimistic rollup, no one can dispute these transactions. So basically, if you submit an update, say to Optimism, and you don't provide the input transactions, you take complete control over Optimism and you can steal all the funds. Not ideal. For validity rollups, it's not that bad, but you can transition the rollup into a state that only the attacker knows how to progress. So basically, I would take, ZK Sync, progress to a state that I don't know, and then no one can move their funds unless I do. So I will go to you and say, hey, give me 50% or I don't give your money. So not that bad, but still completely destructive. So now the job of L1 is guaranteeing data availability. And who has to do this guarantee? Who has to do these checks? Who has to check that data is actually available? Everyone. That's the main problem. That's why this is such a hard problem. And this is kind of the last stage on blockchain scalability that we are triggering. So to make you understand why this is the case, why everyone has to check it, I want to explain this case. If you have never seen this slide before, please pay attention. This is absolutely critical to understand why blockchains go the way they go. So execution that we were talking before is just math. You have 1 + 1 = 2. It's something you can prove, something you can show to L1 that has been done correctly or incorrectly. However, the existence of data is subjective. It cannot be proven. So let's go to the slide. Consider case 1, we have 2 roles. We have the publisher, this guy, and we have the slasher, the one that's gonna like police, make sure that everyone publishes data, which is this one. In case 1, the publisher is malicious and does not publish all the data. But then the slasher correctly identifies this fact and says, hey, not all the data is here, alarm, blah, blah, blah. Now, for case 2, the publisher is honest and publishes all the data. But now the slasher is malicious and falsely raises the alarm. Now you, as an observer, come at T3 at the end and you see these 2 cases. You cannot tell the difference. In case 1, there is an alarm and all the data. In case 2, there is an alarm and all the data. Who's at fault? Publisher? Slasher? We don't know. That's why, yeah, fuck the publishers. Because you cannot know, you cannot build like an incentive structure on top of this. You don't know. So yeah, to recap, execution, we scale with rollups. Execution happens somewhere else. We prove the result on chain. And data availability, everyone has to check it, but we will scale it with data availability sampling. That's the next topic we're going to check. So everyone has to do data availability checks, yes, but there is a smart way that you can do these checks in a way that scales. So the naive approach, what's happening today in Ethereum and all blockchains, is everyone downloads everything. So the data is inside the blocks, everyone gets the blocks, so everyone checks everything. This is very safe, but it doesn't scale. The next idea, a bit naive, would be just check some of the data. Just go on the blog and say, I'm going to check this bit and that bit and that bit. And if it's mostly available, then I guess it's mostly available and blah, 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 we continue. That scales, of course, but it's not safe. Why? If only one single transaction or even 1 byte of one transaction disappears, those terrible attacks, the ones that you can steal everything from optimism and staking, all that still applies. So you need a way to ensure that all the data, like 100% of the data, has been published. And that's why we come to Azure Code Extension. And this is kind of the key magic that makes everything possible. Instead of sampling the data itself, we will extend it with a polynomial. So if now we have only 50% of the data, we can just compute this polynomial and extract the data back. So now the question is not all the data is available, but 50% of it. And these cool properties, now I'm going to just pick some sample, pip, poop, pip, poop, pip. And if these samples are available, then we have a probability of 2 over the number of samples I have chosen that 50% of the data is available. Math, but in practice, what it means is this. Now, like with probability sampling, if you check 10%, then you have 90% chance that you will be full, that it's actually unavailable. But with the extension, it's practically 0. It tends to 0 very quickly if you have enough samples. So, which is great. You know, you see, check a little bit, never fooled. Excellent. So, this new data that I'm talking, like these extensions and polynomials, all of this, it's already on Ethereum. It's already in chain. With this new space that we call blobs. So now we have block space for transactions and blob space for the transactions that accompany these blob transactions, and that's where Rollup put the data. The cool thing about detaching the data into something else is that now we can do different things with these blobs. We can expire them. We can make them cheaper because blocks are kept forever on the clients, so you need a lot of gigabytes. But the blobs, after 2 weeks, they're gone. So we can have much more throughput without sacrificing on home stakers' capacity to store data. And the other cool thing is that blobs have their own fee market. So we have one gas price for block data, like the gas price, the one that you know and love. But blobs, they have their own separate gas market. And so far, that has proven to be very useful. I'll show you now some graphs. And it has resulted that blobs has been free basically since launch, which is quite cool. So far, all of this is like the long-term roadmap of what's going to happen with data availability sampling, blah, 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 and everything. But a couple, like 2 or 3 years ago, rollups were already like scaling and going to production. They were like, come on, give us data. You know, we need something now. And all of this data availability sampling is very complicated. We haven't figured that out yet. So we did this B0, which is called proto-Danksharding, where we do the crypto part and the blob, separate fee market and blob space first. So we can deliver already. This is already in production since March. And rollups are happy. So what has been the adoption so far? I would say pretty good. So we did the fork on March. Here we had block descriptions. Not sure if you remember, but that kind of blew up. And then the market has been flatlining on the top. And we have like adoption from all these very cool rollups. And because they don't actually reach the maximum, which should be around here, the fee is actually 0 for most of the time. Or, I don't know, 1 to e to the minus 18, something like close to 0. Which is very cool, because if now you want to transact on Base or Optimism, the fees are 0, I guess. Like, not exactly 0 for reasons, but practically 0, which is cool. It's maybe not going to be like this forever, but it's nice. Like, it's the first time since forever that Ethereum is a little bit under capacity. And this original goal of democratization and allowing different types of activity, it's kind of coming to our reality, which is really exciting and bullish, in my opinion. However, some people think otherwise. So because fees are low, now we are not burning ETH. And ETH has been inflating again. So I wanna do a question for you guys. Again, what happened here is we scaled Ethereum, fees went down, so inflation is up. The fact that Ethereum is inflation for low fees, is that a bad thing? Raise hands. Is that a bad thing? Or is that a good thing? Okay, there is no right and wrong answer. Like, this is economic policy. I think, yeah, maybe in my honest opinion, if I had to say, I think this is a good thing. Like, Ethereum inflation is fine. Like, we should prioritize the fact that Ethereum is useful to as many people as possible than to reward holders. But again, that's my take. Cool. So now that we have proto-Danksharding on mainnet, the next step is to actually do sharding. That's what we're working on. And you can understand sharding with this ratio of how much capacity exists on the chain versus how much capacity you, as a node runner, have to download and process at home. Now we are here, no sharding, so you have to do everything. But as we move down the roadmap, you will have to do less and less and less. But getting to these high degrees is really, really technically difficult. So the first step, which is what we're going to talk today, is PeerDAS. That's some reasonably modest sharding factor, but still quite good, because remember, we are not at capacity. So if we double, we'll go above the roof just with a 2x. So rollups need, I don't know, some way to catch up and just onboard more users, whatever. And yeah, to recap, why is sharding hard? So when you shard, now you need to find and retrieve this data from parties that you don't know where they are. So there needs to be a lot of network constructions to find those peers, retrieve this data, and do some operations that are complicated and expensive, like reconstruction. We're going to talk that later. But yeah, doing that quickly enough for blocks to become canonical in the attestation deadline, which is 4 seconds, that's pretty complicated, and we haven't figured that out yet. So we can do that now safely with a 2x, but for like 64x, we need crazy network constructions that we haven't figured out yet how to do. So to give you some visualization how this is going to look, today we have these blobs, and we will represent them with rows. So this is just data. We don't care, just random data from rollups. Now, with sharding, 1D PeerDAS, we will take these rows and we calculate the extensions, the polynomial extensions we were talking about. This is this orange line. And now we chop them vertically into columns. So a column is the unit that we're going to move in the network, both for custody and sampling. And it includes a chunk of every single blob, or it could be the extension. Doesn't matter. Remember that we have to sample the full space, extension and non-extension, so that if we get 50%, then we can run reconstruction and get the blue one, which is what matters to us. So how it's going to work? We have the proposer. We have the proposer who's going to compute the extension, this thing we saw before. This is some relatively expensive cryptography. Then it's going to chop them up into columns, and it's going to know which custodians expect which columns. So it's going to forward them, publish through gossipsub. That's the first step, and this is called subnet DAS. We'll explain it now. And then the second step is actual PeerDAS. So this group of samplers, sometime after, will discover these custodians via this P5 and query them over regresp. These terms don't matter much, but what's important about them is that these are not new network constructions. These are protocols that we have been using on production for 4 years now. We understand them very well. We have implementations. They are safe. It's just that the way they are used here is novel. And because of this novelty, the problem now that we find is timing. They work, but they are a bit too slow. So you, as an attester of the beacon chain of Ethereum, your key role is to vote on what block is the head and what checkpoint you want to justify. And you have to do that 4 seconds into the slot. That's quite short, especially because today with MEV, and I'm not sure if you heard about timing games, the proposer has an incentive to publish as later as possible. So I think now the median, so if this is 0, now the proposer is actually here, proposing here, when it should do here, but they are greedy. And the thing is, the later you propose, the more MEV you capture. So proposers have an incentive to delay publishing. And that's kind of messing up this window. So if we expect participants to sample within this deadline, what's going to happen is that some people will be left behind. And guess who's going to be left behind? It's going to be the solo stakers. The people with the least resources will be penalized, will vote on the incorrect head, and will have an economic penalty. So this would become a centralization factor. And we don't want that. So what we come to the realization, well, especially Francesco, he's a very smart researcher at the EF, is that we actually may have a better option. So to recap, in sampling and dataability sampling, we need to provide these 2 key properties. So this one is the most important, which is global safety. We want to ensure for rollups that blocks are available with very high probability. Or in other words, that a block that's not available will never become canonical and finalize. So that at most, a small minority of sampling nodes can be tricked. That's very easy to achieve because it's just a probabilistic statement. If you have enough of this, getting enough columns at random sections, just for like sheer overlap, you can provide this guarantee. Then the one that's more hard is individual safety. So it's you, on your own point of view, can you be tricked by a malicious proposer into believing that something is available when it's not? And that's very hard to do, because imagine that you are the proposer and you know that the sampler node number 15 wants columns number 1, 2, 3, 4. So you just get these columns and give, hey, here you are, these columns. And then you hold the rest. Then the node would believe that it's available when it's not. So in order to achieve this one, we need a way for samplers to be more anonymous, or to be precise, to have the queries that they have be unlinkable and ideally distributed amongst different participants. But with this initial step, which is subnet does, that's very hard to do because it's very public. So what we're going to do is we're going to divide these two sections, and we're going to say we sacrifice like the second property. So we move the attestation deadline forward only to the first step of distribution, to the custodians. So that way, we don't have this penalty that if you have slow sampling, you can still attest to the correct thing. The problem now is that this attesting vote doesn't have as much weight, so it's a bit more unsafe. So what we will do is make these guys hold much more data. So we still have a safe construction, but the sharding coefficient may go from 4 to 2. But that's OK. We can iterate later. So yeah, to compare subnet sampling, this is the initial distribution we do over Gossip Sub. It's relatively efficient, but it's quite expensive in terms of bandwidth, because due to how the protocol works, data gets distributed 8 times its value. And it's also extremely easy to trick a node into believing that something is available, because you have to announce ahead of time, hey, I need column 1, 2, 3, 4. Instead, peer sampling is much, not a lot, but reasonably safer in this regard, because you don't have to announce ahead of time what columns you want. And it's perfectly bandwidth efficient, because you just do one request and you get one response. The problem is that this is much slower. So we're going to probably do a construction like this in the future, where we sample, but we take more time, like 6 minutes. And then this signal will not be used for attesting, but it will be used for transaction confirmation, block proposal, and justification. So for now, I think the first iteration of PeerDAS, we would do custodians distribution and done. So this is much easier to pull off. In initial devnets, we have seen instability with sampling. So if we just do subnet DAS, we can deliver this sooner and do the 2x now. And then when we figure this out, we do the 4x, and we just keep going. So far, the progress we did, so this was a big milestone. We went all the core devs working on this to Kenya and had a bit of like a hackathon, week-long hackathon, where we significantly progressed on PeerDAS and got the first devnet. Then we did the second devnet on July, which died very quickly. Then we did the second devnet on August, which is still alive. And hopefully by Q4, we'll have production implementations. We'll see maybe with peer sampling or not, still undecided. And then hopefully, yeah, this is very optimistic. I would say 23 Q1, let's put it that way, the Pectra hard fork with PeerDAS. So just some random metrics to show that I'm not bluffing. We are actually doing this. We have nodes today running that. I think it's still too early to measure in terms of pure bandwidth what's the actual factor that we're getting. But so far it's looking good. I'm optimistic. Clients are getting quite productionized now. And yeah, we'll see in the next 4 months. We'll be ready. So yeah, that's PeerDAS. Now, roadmap, next steps is we'll keep going. We're not going to stop. If we get to here, we'll have this end game that Vitalik wants to call like the 32 megabyte block, where we can have like tens of thousands of transactions per second with a ton of rollups. But to get there, we need to do this. And this is much more complicated, because what's going to allow here is that to get to this very high sharding level, we need the load on the single node to be really, really, really small compared to the amount of data. So, I mean, we don't have time to go over this, but the key idea when you see this picture that you may see in the future is that instead of sampling the whole column, now you're sampling a single square. And this is going to be really big. Like we're going to have, this is going to be huge. So this cell is going to be tiny, just kilobytes of data. And if you just check like 32 of them, you can prove to yourself that the data is available. And that's the magic of this construction, that you have a huge amount of data and you just available, both, and done. So yeah, thank you so much. Hope it was not too overwhelming. I think we have time for some questions.
Yeah, so you said there was a probability of 0.0001% of one of the slides. Yeah, where you had listed there is a 0. Yeah, I think after that. Yeah, here. So I mean, considering the amount of economic value that is stored in blockchains, if we attribute an economic value to this, that is still significant, right? The point that I'm trying to make here is, I mean, terrific, great approach, loved it totally. But someone still needs to solve for long-term data availability, and where everyone downloads everything, but in a more infrastructurally efficient manner. I'm not sure, I'm not in this field, but I heard like some Covalent is building an Ethereum Wayback Machine or something. So is that also a need for the industry?
Right, so that's a great point. So the whole point to provide this level of scalability is to make the blob data expirable, and that's essential. It doesn't mean that other types of services or industry can take on the role of keeping that data, and that's what's already happening. If you want to access all blob data today, because it has already been expired, you can go to Etherscan or Blobscan or services like this that they would give you the data if you want. But it's not the role of the protocol anymore, and we have to do that, otherwise it's not going to scale. If you, I mean, hopefully not, but if you, so what he's mentioning is that Etherscan may also remove the data. And I don't think they will, because they have an incentive to keep the data. And it's not that expensive to keep the data. The key point is that we are removing this responsibility from testers, from the validators. So you have to think on the home staker. Now the home staker don't have to keep this data anymore. It can forget about it. So now it's the role of a different type of entity. And if you are a rollup or an exchange, in other means someone that's really, really interested in having this number with 99 zeros, then just keep all the data yourself. There is no one that's preventing you from doing that. Or this number could be much bigger if you just sample a lot more. Or if you're really concerned, just get all the data.
Is that part of Ether technology or it's your own chain? Sorry, is that part of Ether technology or it's your own chain? I mean, that solution will be included in near future in Ethereum, or it's something different project?
Yeah, everything we talked today is on Ethereum mainnet.
No, but you say mainnet, so I'm asking about that solution that you present. So the future sharding, it will be part of Ethereum, right?
Yes.
And you think it's really possible that in next year it will be in mainnet?
Yes. PeerDAS next year mainnet, I would say 90% chance or 100%.
Any more questions? No.
It's so difficult, sorry.
Thank you.
Thank you. Thank you.